Okay, hello everyone. So in this lecture, we'll be discussing Ohm's law, the related parameters to Ohm's law, and there's one important formula or derivation of resistance. All this will be covered in this lecture, so you have to keep your notebook handy to write down all these derivations and important numericals. Okay, so moving forward, first you have to understand how an electron, flows in a circuit, how current flows in a circuit. So if you look at the first diagram, so there is fluid flowing in this pipe. The fluid will only flow if there is what? If there is pressure difference. The fluid will only flow if there is pressure difference in the pipe. And pressure difference is created by either a pump or gravity. So if there is pressure difference, then there will be flow of fluid. Similarly, in a wire, there are electrons, and electrons will only flow if there is potential difference. So if you will create potential difference, then there will be flow of current. So current flows when there is potential difference across a wire. So what is the relation between potential difference and current? So how change in potential difference will change value of current? That is basically Ohm's law. So according to Ohm's law, it states that current through a conductor between 2 points is directly proportional to the voltage across the 2 points, keeping external factors such as pressure and humidity constant. Now pressure, humidity, temperature, they can change the properties of material, which will change the value of current. So if we will keep those properties constant, and if we'll change V, then there will be change in I. So I is basically current and V is basically potential difference. So potential difference is directly proportional to current, or we can say current is directly proportional to potential difference. So more the potential difference, more will be the value of current. Remember, this is a one-way thing. Like if you will increase the potential difference, then there will be increase in value of current. So I is directly proportional to V, and we can also write it to be V is directly proportional to I, and replacing the proportional with a constant, that is R, and or R is called as resistance of the wire. Now remember, by replacing the directly proportional, we have put a constant. This constant will not depend on V and I. So value of R is independent of potential difference and current. If you'll increase V, then I will increase. If you'll decrease V, then I will decrease. R will not change with change in V or I. R is a constant which depends on some another parameters that we will discuss in upcoming slides. So always remember the graph of Ohm's law, the statement of Ohm's law, and the formula for Ohm's law. So potential drop or potential difference across a wire is basically equal to current flowing in the wire multiplied by resistance of wire. So basically the graph of V and I, for a limited value of current will be straight line. So a basic question that generally comes in our exam is, if there are two graphs, one of resistance R2 and another of resistance R1, and we have to find out which resistance is higher. So remember, if this angle, the theta 2 angle of R2 is more than theta 1 angle of R1, since theta 2 is more than theta 1, so R2 will be greater than R1, because R is basically V upon I. So R is basically slope of VI graph. Now the upper graph will have more slope and the lower graph will have lesser slope. So more the slope, more will be the resistance for VI graph. Suppose it is IV graph, then it will be, inversely proportional. So more the slope, less will be the resistance for IV graph. For VI graph, more the slope, more will be the resistance. Now we will discuss a numerical here. Suppose when potential difference of 100 volt is applied across a wire, 10 ampere current flows through it. What will be the value of current when 50 volt is applied across the wire and what will be its resistance. Now see, if you'll change V, then I will change. Value of R will not change. So from first condition, we'll find out value of resistance. So V1 is 100 volt and I1 is 10 ampere. So R will be 10 ohm. Now using this value of R in the second condition. So what will be the value of current when 50 volt is applied? So V2 is 50 volt, R is 10 ohm. Again putting Ohm's law, current will be 5 ampere. So this is how you have to calculate value of current or voltage or resistance using Ohm's law. The basic and most important thing is that value of R does not depend on V and I. If you'll increase V, I will increase. If you'll decrease V, I will decrease. R depends on some another parameters that we will discuss in upcoming lectures. Suppose we have a VI graph. So at 12 volt, suppose current is 6 ampere. Now you have to find out the value of resistance. So V is basically equal to IR. So putting value of voltage to be 12 volt and putting value of current to be 6 ampere, resistance comes out to be 2 ohm. So you have to learn how to use graphs to calculate values. This is one example. Also examples there will be in the quiz also. So you have to learn all these things. Huh? So there are few important relations that we can derive from the formulas that you have learned till now. First one is Ohm's law, that is V equal to IR. Second one is relation between potential difference and electric field, that is V equal to E into L. And third one is formula for current, that is I equal to A N E V D. Now putting value of V to be E equal to L in Ohm's law, that is V is equal to E into L. Putting value of I to be A N E V D and resistance is kept like that. So if you'll put value of net velocity, that is minus E tau by m, then electric field and electric field will cancel out and formula for resistance will come out to be m into L divided by A N E squared tau. Now if we look at this formula, then value of resistance depends on mass of electron, that is a constant. Value of resistance depends on length of wire, depends on area of cross section, depends on number of electrons per unit volume, charge of electron and relaxation time. So this is formula for resistance. If you will see, the value of R depends on most important length, area, tau and n. So basically R depends on type of material and dimensions of material. This formula we are again going to discuss in upcoming slide on resistance. So to remember this formula, and now you have to submit an online quiz depending on this slide, what formulas we have learned in this slide, mainly Ohm's law and graph. If you have any doubt, you can send me. Have a great day.